Welcome back everyone to another episode of the Doom series, and in this video we are going to learn how to make our player start at the correct position in the map. So in order to do that, we need to find information about where the player is located in the map. So for that we actually need to load another lump in our game, and that lump is the things lump. So I'm going to open up map.h and what.c. In map.h I'm going to go here where we've got our map. You can see we have got two more variables here. One is the number of things, and then we have got a pointer to an array, well, a pointer to things, basically an array of things. This will be dynamically allocated, of course. And here we have got the actual thing structure. Now each thing consists of three values. One is a UN16, which is the actual type of the thing, and this is a single integer inside of the engine, that represents what the thing is. Then we have got the position and then the angle. There are also flags on the thing, but we don't care about those for now. So we have got these things here. So we have got the type, the position, the angle, and we also got the flags, but we are not really caring about that right now. And in what.c I'm going to go down here where we are actually we have got another function here, which is what read things function. Just read things actually, and this is used as you can see here inside of our what read map function. It's just used here to read the things as well with the things index lump. And what this function does is that you can see it first of all set the number of things to the lump size divided by 10, because each thing is 10 bytes. Then we allocate the memory for the things, and then we move over, just like we are doing with all of the other lumps. We set the position x and y. Similarly here we cast this to int16 so that it's signed and not unsigned. And then for the things type, we just set that to read i16 from the lump data, and this is at offset 6. So the position is at offset 0 and 2, while the type is at offset 6. And at offset 4 we have got the angle. Now the thing is, angles in Doom are stored for the things, in the things we have got the angle stored as degrees. So for that, we at the offset 4 we have got the angles as degrees as an int 16. So we load that and we store that in a float. Now we need to convert this to radians, because that's what our engine uses. So for this we take our for the things angle, we just take the angles, multiply it by pi by 180. And the reason we add this pi here is because by default the Doom angles are like facing towards east. So at 0 degree it's supposed to face toward east, while in our engine it's not gonna work exactly the same way. So to make sure that the rotations are correct, we just add pi to it, and it makes that work. Now this is the thing, and you might be saying that this contains very few information, like only the angle and the position, and it doesn't contain like how big the thing is, the height of the thing, or all of the other stuff. And the reason for that is because this type is used to refer to an internal table in the engine, and that table determines what information we have. So if I go up here, we've got an enum here, things type, where we are just going to store the constants for the actual things type, which represents the UN16 type that we have got in there. So the only thing we have got here is the thing player 1 start. So this is the position where the player 1 is supposed to be spawned, and the type of this is equal to 1 in the engine. I'll have a link to all of the thing types in the description. You can find a table there and check it out. And we have also got another structure here that I have defined, which is the thing information structure. Currently it of course has a type which represents the actual type for this, which this is the information, and then it has got the height. And as far as the height is concerned, we are going to use that to determine how high to place our camera. There are also other informations and stuff, but we don't really care about those right now, so we are not going to add that. And here we have got two new variables. One is the number of thing informations that we have got, and one is the actual array of thing informations. Now these are basically two arrays, and the reason we have got this like this is because these are extern, which means they are going to be defined elsewhere, so that if we change anything we don't have to recompile our whole project, which includes the map.h header file. So for that reason we actually make them extern, and now we have got a new file map.c, and we define these in here. Now currently the number of thing information is just 1, because we have only got for the player 1 start, and in here for the actual information you can see thing p1 start is the id, and for the height it is actually 56. And as I said, I'll have a link where you can find all of the information and stuff in the description, so that you can check out if you want to look into other things as well. So this is just supposed to be hard coding in the engine, which we are going to reference whenever we are spawning a new thing. So that's all of the basic stuff out of the way. Now let's go under engine.c. Now in here what you'll notice is that inside of our engine init function we no longer initialize the camera here. The reason behind that is because the camera will now be initialized based on the thing. So if I go here, you can see that where we are looping over the things, you can see we set our thing pointer to map things, the current thing. So we basically loop over each of the things in the map, and then if the type of the thing is equal to player1 start, then we first of all have a create a thing info pointer which we set to null, and then we loop over all of the informations and check if our things type, which is a player1 start, is equal to the map thing infos type. If it is, that means we find the correct information, so we set the pointer to that value and then we break from the loop. And if it is null, that means that the information for this wasn't found, which means there's something wrong, so we just continue and don't initialize the camera. Otherwise this should not happen unless you got this table messed up somewhere. So now we are going to set our camera, and what we do basically is that we set our camera's position to the thing positions x and y, while the y is the x and z position are equal to the thing's position x and y, and this is of course negative because of how our engine is organized. But as far as the height is concerned, the actual y value of the position is concerned, the vertical axis, we set that to the information's height, which means that we will be our camera will be like at the top of where the actual player is. And then for the yaw, we set that to the thing's angle. However, for the pitch we just leave it at 0 because well, that's how it's supposed to work. No pitch in the original Doom. And now you can see that it actually starts at the correct position. So this is where the even M1 map is supposed to start. Alright guys, so in here you can see that I am also going to do a couple of other changes, which is that we are going to change our movement to actually match the original Doom movement more. So in Doom you cannot move up and down, obviously you can only move in like a 2D plane. So for that now we can store two local variables, the forward and the right, as the camera's forward and right vectors. Then we zero out their y values and normalize them. The reason we do this is because well, we need to normalize so that the speed isn't slowed down when we are looking down, and also we need to set the y of both axes to 0 because y of right and forward both to 0, because we don't want the player to be able to move up or down. And then we use these local variables when we are doing all of this, and along with our key w we also allow key up and key down for moving forward and backwards. And here all of the other stuff is pretty much the same. Now we also allow turning with the help of a keyboard. So for that we have got a turn speed here, and if our right or left key is pressed, then we increase or decrease the camera yaw by the turn speed. The turn speed is just 4 right now, and it multiplies by the delta time. And then for the capturing logic, I have changed that a bit. We have changed it so that instead of making it so that the mouse is captured as long as we are pressing the right button, now the mouse will be captured when we press the right button and will be released when we press the escape key. So for this we just go ahead and if the escape key is pressed, then we set the mouse to be not captured, and if the right button is pressed, then we set it to be captured. And if the equal key is pressed, then we zero out the camera's pitch. So if you're looking around and then you want to orient yourself back to the normal thing, then we press the equal key, and that will set the camera's pitch to 0. Now when we are doing all of this logic, we have got a static bool here called is first, because now we are no longer relying on when the user presses the button, so we need to kind of do it this way. So if our mouse is captured, then we check if this is the first time this is running, so the mouse was just captured the previous frame. If that's the case, then we set the last mouse to the get mouse position, and we set is first false. So this will store our position here correctly, and then we go over and do all of the other stuff that we were doing just like we were. And here in the else we don't do any other checks, and we just set the is first to true if the mouse is not captured, which means that the next time it's captured, that would be the first time. So this is all pretty just simple stuff, and now you can see that we kind of move around like we moved in the original Doom. And the obvious problem is that currently we move around at a single height, so we are not actually changing to reflect the height of the sector that we are currently in. So this is a bit of a problem. We need to change it so that we actually show the height of the sector that we are in instead of this way. This is kind of weird, so we need to kind of fix that problem, which isn't too difficult, but it will involve traversing the PSP tree. So we'll be doing that in the next video, so stay tuned for that. I'll see you in the next one. Make sure to like and subscribe as well, and share this video with other people, and I'll see you in the next one.